this video, we're going to look at the Module 7 SAS code. So there's three pieces of information you're going to want to make sure you have handy. The first one is the Module 7 SAS code file. You'll also want to make sure that you have your codebook handy. So just as a reminder, here's what the codebook looks like. And then finally, in Module 6, if you'll remember, we took the large BRFSS data set, and in the videos we saw how to subset that data for Kentucky, and then for the exercises you subsetted that data for your state. So for this particular video, I am going to use that smaller data set for Kentucky. When you work on your practice exercises, you'll want to use the small subsetted data for your state. Alright, so the first thing I'm going to do is read in my data set. So I'm going to use the proc import statement just like we did before, and notice here with my file name I am reading in that smaller data set that we made last time. So I'm going to run this, and you'll notice down here at the end it will tell me it was successfully created, and you'll notice that it has a little over 6,000 observations and 275 variables. That is exactly what we would expect to see for this data set, because if you'll remember, that's what we had in the Module 6 video once we subsetted our data for Kentucky. When you work with your state, you should see something similar that matches with the number of observations your state had from Module 6. So again, we're going to focus on summarizing quantitative variables in this video. In the notes, one way you saw to summarize quantitative variables was using a dot plot. The BRFS dataset is very large. Dot plots wouldn't be useful for this dataset. So in this video, we're going to primarily focus on how to create histograms. There are other ways to visually summarize quantitative data, and we'll actually look at some of those later on in the course. So the variable I'm going to explore in this video is the num women variable. So the first thing we're going to do is go to the codebook and explore that. And so just as a reminder, in the codebook, if you click on the codebook and hit Control F or Command F if you're on a Mac, this will bring up the Finder, and you can type in the variable name and use that to find the variable in the codebook to read about. So this is one way that you can navigate the codebook. You can also use this if you're looking for variables. So for example, if you were looking for a variable that dealt with a vaccine, you could type the word vaccine. Now be careful though, that's not saying that all variables that are useful will show up in that search. It will only show up if that word is used exactly in the document. So do be aware of that. So we have the number variable, or num women variable here. So if we look down, what this variable does is it records the number of adult women in the household. It was used in the landline survey. And so if we look here, we can see this variable takes the values 0 through 99. And what those numbers will represent is the number of adult women in the household. So this is a quantitative variable. The values that are recorded do match with the value label in terms of what that value label is representing. So, if we had 79 women in the household, it would be recorded as 79. Now, you do want to be careful when you're looking at identifying quantitative variables, because some values that are numeric are going to represent ranges of numbers. So for example, if you were looking at the variable age, and here in the value label it said something like the value 0 represents ages 0 through 25. That would not be a quantitative variable because the actual values would be categorical. So do be very careful, because even though these values are recorded as numbers, what they represent actually determines whether or not your variable is going to be categorical or quantitative. The other thing you want to be careful about is when we look at these values. Now this particular variable, you'll notice that if it's blank, it represents missing, and we don't have any options that are like refused or unknown. There may be some variables that are quantitative with the exception of refused and unknowns. In cases like that, we can reset the refused or unknowns to be missing and then analyze it as a quantitative variable. But as always, if you remove the refused or the unknowns, you have to make sure you record that those were removed and you're only analyzing those that responded. So it's always going to be about transparency when you remove those values. All right, so let's go back to our SAS code and talk about what we're going to do here. The very first thing I'm going to do is use what's called the proc mean statement. Now, we're going to talk more in the future about numerically summarizing a quantitative variable, so looking at things like mean and standard deviation, but we haven't done that yet. The main thing that I'm going to use the proc means statement for is to help me figure out if there's any missing data for this variable. So let's run this, and you'll notice here I've just given it the name of the variable, the name of my data set. So these should be the only two pieces of information you'll need to change. And when I run this, so I get some information here, but the main thing I want is this piece here at the end. So this tells me how many actual observations I have that are not missing. So remember, my data set has over 6,000 observations, but this particular variable only has 2,353 observations that were recorded. So this particular variable has a lot of missing data. So it's very important that we record that. So what we'll want to do in our histogram is we'll want to make sure that we put a footer and say how many missing values there were. So in this case, to find out how many missing values there are, what we can do is we've got from the previous page, remember we know how many total observations were in our data set, and we could pull that from the log. If we go back up here, remember there were 6,604, so if we subtract off the number of actual observations, we have a little over 4,000 missing. Alright, so next we're going to create the actual histogram. So what I'm going to do is I'm going to run this, and then I'll actually talk about the different pieces, but let's run this piece of code and see what the histogram is going to look like. So here's our histogram. Notice we've got a nice title. Both of our axes are labeled. In this particular case, I made the histogram red, and here on the left we do have percentages. And remember, for the epi profiles, that's really what we want, our relative frequencies or percentages on the y-axis, just like with the bar plots. So let's go back to the code and see how we made this. So the first line here we need is the data. So we need to say what data set we're using. The title line is going to give it the name of the plot, and you'll notice here at the end, got an extra space there, I added in parentheses n equals 2,353 to let the reader know that there were 2,353 observations that went into making this particular plot, and that number came from where I ran that proc mean statement. The histogram, that tells it to make a histogram. I give it the name of the variable I'm using, and then everything after the /, these are going to be different attributes of the histogram that I want to change. The first one here is bin width. Okay, so bin width, what that's going to do, if I kind of move over my plot, notice that the width of my bars, all of these represent a count of 1. Now, if we think of the number of adult women in a household, it would make sense for each of the bars to represent a width of 1. Because we've got whole numbers here, we know it's pretty unlikely that we've got more than 6 adult women in the household, so most of our values are going to fall in here. So a bin width of 1 makes sense. I wouldn't want to do a half because that's going to end up giving me spaces. So bin width of 1 works well for this variable. For other variables, you might want to change the bin width to be something else. For example, if you make a histogram of BMI, a bin width of 1 would not be a good choice. You might consider a bin width of 10 or 20 there for BMI. Filters equal color equals red. This whole piece right here, that is what's changing the color of your histogram, and you can put a different color here. And then scale, that's actually is what's giving us the percentage over here. You can also do scale equals count, which would give you the frequencies, or scale equals proportion, which would give you proportion instead of percentages. And then finally, the y-axis and the x-axis label, that's what is actually labeling our axes. And so notice, since our scale is in percent, we've labeled our y-axis as percent, and the x-axis label should, tell us about the actual variable that's being visualized in this plot. So then other than that, that is all the code you need for histograms. So again, to change this code, the main things you're going to be doing are changing the data set, changing the title. You'll want to change the variable name to be the variable that you want. Bin width. Now to start out with, if you want to, you can actually take this out and run it and see what bin width SAS uses by default to see if it looks nice. If not, and a lot of times it won't, you'll add this bin width in and then choose a reasonable bin width based on the variable that you have. And so you might want to play around with that just a little bit. You can change this color scheme right here to have a different color. And then for your epi reports, I would probably keep scale equals to percent. You could also do proportion here, but I would not do count. If you change this to proportion, I would change your y-axis label to proportion. Otherwise, leave that as percent or percentage. And then finally, for the x-axis label, you'll want to change this to, match the variable that you are summarizing. So as always, if you have any questions with this, please let me know. And I hope that you have a wonderful week.